Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. Pricing in AWS is built on a pay-as-you-go foundation, but this flexibility comes with a rich set of options for optimization. At its simplest, AWS charges you only for the resources you actually use, whether that means compute time, storage consumed, or data transferred. This model shifts cost from large upfront commitments to incremental operating expenses, which is a major appeal of the cloud. But AWS also gives you ways to commit for discounts, experiment with pricing models that fit your tolerance for risk, and apply governance to keep spending predictable. The real challenge is matching workloads with the right model, balancing flexibility, cost savings, and reliability. By understanding the fundamentals, you can control your AWS bill with the same precision you bring to your technical designs. On-demand pricing is the default model and perhaps the most intuitive. You spin up a resource, such as an EC2 instance, and you are billed by the second or hour depending on the service. When you stop the instance, the billing stops too. This makes on-demand excellent for short-lived experiments, unpredictable workloads, or environments where you cannot predict usage. The trade-off is that you pay a premium compared to discounted models, but the value lies in not being locked in. For exam purposes, remember that on-demand equals flexibility. If the scenario emphasizes uncertainty or short-term usage, this is the model to choose. It is the foundation upon which other options build. Reserved instances, often shortened to RIs, offer significant discounts in exchange for a 1 or 3 year commitment. They are especially popular for compute and database workloads that run continuously and predictably. RIs come in different flavors. Standard RIs provide the deepest discount but least flexibility. Convertible RIs allow changes to instance types within the same family, and zonal RIs add capacity reservations within specific availability zones. The underlying logic is simple. By committing, you give AWS predictability, and in return, you get lower prices. On the exam, when you see steady-state workload or always-on database, think of reserved instances as the go-to cost lever. Spot instances flip the logic entirely by offering steep discounts, sometimes up to 90%, but with the caveat that AWS may reclaim the instance at short notice if capacity is needed elsewhere. This makes them excellent for workloads that are fault-tolerant, such as big data analysis, rendering, or batch jobs that can resume after interruption. The exam queues are cost-sensitive, interruption-tolerant, or parallel batch processing. The trick is recognizing that Spot is never appropriate for production systems needing steady availability, but perfect for workloads, where time flexibility is more important than uptime guarantees. Spot represents the discount with risk end of the spectrum. Many learners overlook the AWS free tier, which provides a limited but useful allowance of services at no cost. It is divided into 3 categories: always free services, 12-month free services after account creation, and short-term trials. For exam purposes, the free tier is not just trivia. It reflects AWS's approach to enabling experimentation without upfront cost. The boundaries matter. Free tier resources are not for production-scale use, and exceeding limits incurs charges. When the exam mentions trial usage or testing before scaling, free tier is the context to remember. It is more about accessibility than long-term cost savings. Networking often hides costs in surprising ways, especially data transfer. While data ingress is typically free, data egress outbound traffic carries charges. Transfers across regions or out to the internet can add up quickly, especially with content-heavy applications. The exam queues are data transfer costs or unexpected network charges. Recognizing that egress is where costs accumulate helps you design more cost-efficient architectures. For instance, using CloudFront to cache content closer to users reduces origin egress. Similarly, using VPC endpoints or private link keeps traffic inside AWS, avoiding unnecessary transfer charges. Awareness of these signals separates cost-savvy architects from those caught by surprise bills. Storage pricing also follows clear pillars. Capacity charges are based on the volume stored, while request charges apply for operations like put, get, or list. Retrieval charges may apply for archive tiers like Glacier. This structure means cost optimization involves not just storing less data, but also considering access patterns. On the exam, scenarios might ask about infrequently accessed backups or long-term archives. The right match is lifecycle policies that shift objects into lower-cost tiers. Understanding these storage pricing pillars helps you align both performance and cost. Standard for active data, standard IA, or Glacier for archives. Managed services add their own pricing styles. Instead of paying for underlying instances, you pay per request, per gigabyte processed, or per hour of use depending on the service. Lambda, for example, charges based on number of requests and duration of execution. DynamoDB offers per-request pricing in on-demand mode. Amazon Athena charges per query, measured in data scanned. The exam tests this by framing scenarios around pricing drivers, millions of requests, duration of code execution, or data scanned per query. Recognizing these signals ensures you choose the right service not just technically, but also economically. Tagging is another foundational cost practice. By applying metadata to resources, you can allocate costs to teams, projects, or departments. This enables showback and chargeback models, which are essential in multi-team organizations. The exam may use language like identify which team is responsible for spend, or allocate charges across departments. Tags are the key enabler. Without tagging, cost analysis tools cannot attribute expenses accurately. For learners, the lesson is that tagging is not just about organization. It is the link between resources and accountability in cloud billing. Budgets in AWS allow you to set thresholds and receive alerts when spending approaches or exceeds them. This is a proactive control, letting you catch overages before they spiral. On the exam, cues like alert when costs exceed a threshold point directly to budgets. It is not about deep analysis, but about guardrails. In practice, budgets help finance and operations teams collaborate, ensuring surprises are minimized. They form the first line of defense against runaway spend, a simple but powerful governance tool. Cost Explorer provides more detailed insights. It lets you view trends over time, identify usage spikes, and explore right-sizing opportunities. Unlike budgets, which are preventative, Cost Explorer is diagnostic, showing you what has happened and where optimization is possible. Exam phrasing like analyze usage trends or identify cost drivers cues Cost Explorer. Together, Budgets and Cost Explorer form a balanced toolkit. One prevents issues, the other investigates them. This highlights the broader principle that cost control requires both monitoring and analysis. For organizations needing the deepest level of analysis, the Cost and Usage Report, often abbreviated as SCAR, provides line-item detail of every charge. CUR is the authoritative source for granular billing data, typically integrated with analytics tools for custom reporting. The exam might ask about detailed chargeback analysis or tracking exact usage at resource level. The right answer is CORE. While it can be overwhelming in raw form, it enables the most precise insights, feeding into data warehouses or business intelligence platforms. Recognizing when CAR is necessary distinguishes advanced governance from basic monitoring. Finally, the AWS pricing calculator rounds out the toolkit by enabling forward-looking estimates. It allows you to model workloads, inputting expected usage to see cost projections. This helps in planning, forecasting, and justifying architecture choices. Exam questions may phrase this as estimate monthly costs before deployment. The signal points directly to the pricing calculator. While it is conceptual rather than operational, it embodies the idea that financial planning is as important as technical design in cloud computing. For learners, the takeaway is that AWS provides tools not just to monitor spend, but to anticipate and shape it. From an exam standpoint, the recurring cue is alignment. Map workload stability and tolerance to the right pricing model. On-demand fits uncertainty. Reserved instances and savings plans suit steady workloads, and spot works where interruptions are acceptable. Budgets, Cost Explorer, and CR provide layers of governance, while lifecycle policies and tagging tie operations to costs. Pricing models are not just technical trivia. They are part of building resilient, sustainable cloud solutions. Understanding them ensures you can design with both performance and financial efficiency in mind. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Choosing between on-demand and commitment options comes down to understanding workload patterns. On-demand shines when you need flexibility, such as for unpredictable workloads, testing environments, or short-term projects. Commitment options like reserved instances and savings plans deliver lower costs but require steady, predictable usage. The exam often signals this choice with phrases like uncertain demand versus always running workload. Real-world practice is about balance. Organizations rarely live on one model alone. Instead, they mix models to capture both flexibility and savings. Knowing when to lock in and when to stay loose is one of the most valuable financial skills you can develop in the cloud. The first step in cost planning is identifying steady baselines versus spiky workloads. Steady baselines like production databases or enterprise applications fit commitments. Spiky workloads like marketing campaigns or seasonal analytics fit on demand, or even spot. AWS encourages this mindset by providing services that scale elastically, but financial optimization depends on recognizing patterns. The exam might test this by describing a baseline system with variable peaks. The correct answer is often to cover the baseline with commitments and the peaks with on-demand or spot. This hybrid thinking acknowledges that most workloads are not one-size-fits-all, but combinations of steady and variable demand. Portfolio coverage strategies combine these models into a coherent financial plan. A common approach is to cover predictable usage with savings plans or reserved instances, then use on-demand for growth and spot for opportunistic savings. Think of it like an investment portfolio: stable bonds, flexible cash, and high-return but risky equities. The exam cues include optimize cost while meeting unpredictable demand. This points to a blended model, not a single service. In practice, organizations track usage closely and adjust commitments over time, ensuring that spend aligns with actual needs. The cloud's strength is elasticity, and portfolio coverage extends that to pricing. Storage classes and lifecycle policies are cost levers often overlooked. By default, data in S3 standard is priced for frequent access, but many objects grow cold over time. Lifecycle rules can automatically transition data to standard IA or Glacier tiers, slashing costs without sacrificing durability. The exam might frame this as minimize costs for infrequently accessed backups. The correct answer involves lifecycle transitions. The key principle is simple. Don't pay for high-performance storage when cheaper, durable options exist for less active data. This reflects a broader theme in AWS pricing align the resource class to actual usage patterns. Networking costs can be tricky, but they too have levers. Data egress to the internet is often the largest hidden expense. Private paths, such as VPC endpoints or private link, keep traffic internal, avoiding those charges. Exam questions with wording like minimize network costs while keeping access private are pointing to these tools. Similarly, consolidating traffic through Direct Connect can lower cost compared to massive internet egress. The takeaway is that design choices affect not just performance and security, but also cost. A cost-aware architect considers network paths alongside compute and storage. Database costs combine multiple drivers: instance class, storage, and I/O operations. RDS and Aurora charge for compute capacity and the underlying storage, while DynamoDB may charge per request in on-demand mode or per provisioned capacity unit. Redshift, designed for analytics, has its own cost drivers tied to nodes and data scanned. The exam may phrase this as cost depends on instance size and storage, or cost depends on request volume. Recognizing which model applies ensures you select the right service for both workload and budget. The key is to see cost not as a flat fee, but as a reflection of usage type. Monitoring and logging, while essential, can also accumulate costs if left unchecked. CloudWatch charges for metrics, logs, and alarms, while CloudTrail charges for delivered events. Storing massive log volumes in S3 or retaining them indefinitely can quickly grow expensive. Cost hygiene here means applying retention policies, filtering logs to only what is necessary, and using lifecycle rules to move old logs to Glacier. Exam scenarios may phrase this as minimize logging costs without losing compliance. The right response is retention and lifecycle policies, not eliminating logging altogether. This reinforces the theme that cost awareness complements, not conflicts with, good practice. FinOps, or financial operations, represents a loop of measure, optimize, and govern. First, you measure usage with CUR, or Cost Explorer. Next, you optimize by right-sizing, applying lifecycle rules, or adjusting commitments. Finally, you govern with budgets, policies, and tagging. This cycle repeats continuously. The exam might describe this as ongoing cost management with governance. The answer lies in recognizing FinOps as a discipline, not a one-time event. Just as cloud operations are iterative, so is cost management. The cloud is not just pay-as-you-go, it is manage-as-you-go. Showback and chargeback models extend cost awareness to teams. With tagging and multi-account structures, you can allocate expenses to specific projects or departments. This transparency encourages accountability, ensuring teams design with cost in mind. On the exam, cues like allocate costs to departments point directly to tags and AWS organizations. This is less about technical function and more about governance. Showback provides visibility while chargeback enforces responsibility. Both are essential for large organizations managing diverse workloads. Cost-aware design is a meta-theme that runs across the exam. It means thinking about cost implications at the same level as security or performance. Designing with lifecycle policies, caching, or private endpoints are not just technical optimizations, they are cost optimizations too. On the exam, the best answer is often the one that solves the technical requirement while also aligning with cost efficiency. If two options work, the one that is more cost-aware is usually correct. This mindset mirrors AWS's own guidance. Cost is a pillar of well-architected design, not an afterthought. Avoiding pitfalls is part of this discipline. Unused commitments, such as overpurchasing reserved instances, create waste. Surprise egress charges from careless data transfer design can blow budgets, leaving resources running when idle racks up unnecessary spend. The exam often disguises these pitfalls as plausible answers. For example, move all data to S3 standard may sound fine, but for archival data it is a cost trap. Recognizing these pitfalls in real life saves money. On the exam, it saves points. Both come down to the same skill: critical evaluation of requirements against best fit solutions. Continuous review is the final piece. Cost optimization is never done. As workloads evolve, usage patterns change, and AWS introduces new services or pricing models, regular reviews are essential. This is why collaboration with finance partners is so important. Engineers understand workloads, finance understands budgets, and together they ensure alignment. The exam might frame this as ongoing governance of cloud spend. The signal points to continuous review with both technical and financial stakeholders. This is the essence of cloud maturity. Not just building well, but managing sustainably. From an exam perspective, the ultimate takeaway is to align workload stability and risk tolerance with the right pricing model. On-demand is flexible but expensive. RIs and savings plans reward predictability. Spot rewards, fault tolerance, and free tier allows experimentation. Governance tools like budgets, cost explorer, CUR, and pricing calculator complete the picture. If you can consistently map scenario language to these models, you are not only exam-ready, but also well-prepared for real-world cloud design. Cost is not separate from architecture. It is part of it, baked into every decision. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.